Gridshells are highly efficient structures because they carry loads through their curved shape with very little material. Here at the Chair of Structural Design at the Technical University of Munich, we have been investigating the geometric properties of gridshells. And we've asked ourselves, how can we simplify their fabrication? In collaboration with mathematicians and engineers, we have developed a method which allows us to construct gridshells from flat and straight lamellas. Even more, all joints in this grid are identical and meet at precisely 90 degrees. This makes fabrication very simple. Inside Out is the first architectural structure that utilizes so-called asymptotic curves. A catenoid surface is transformed to fit the surrounding footprint of our building site. The designed shape creates two archways and embraces a central tree in this courtyard. After the surface is designed, the mesh is carefully refined to fulfill the geometric requirements of a minimal surface. The asymptotic curves are not freely designed. An algorithm tracks their specific path, creating an orthogonal grid on the surface. The lamellas are constructed along this grid. They are oriented perpendicular to the designed surface. By adding edge profiles, supports, and bracing, this structure becomes an efficient, load-bearing grid shell. The lamellas are cut straight and flat and can be easily manufactured and transported. The construction itself relies on very simple processes. The lamellas are slotted together by hand into flat segments. They are then elastically bent into their curved geometry. By fixing every node to 90 degrees and adding some edge supports, we can freeze this shape. Inside Out consists of 9 of these segments, which are later combined on site, like a large 3D puzzle. We have adopted a strategy of always using 2 parallel lamellas for each grid line. This allows us to bend them in their individual curvature and later connect them to become one strong beam. The pavilion is designed for a beautiful green courtyard at the heart of the Munich campus. At its center stands a tree that is embraced by the structural grid. The varying density of this grid will have a unique effect on lighting and shadows underneath. The pavilion is fabricated from stainless steel, reflecting the colors of the sky and the nature. The structure covers about 100 square meters and spans approximately 9 by 12 meters. Inside Out is not the final result of our research, but it is part of the process. It will be used to examine the behavior of this new construction technique at a large scale.